In the part 2 of this video, we are going to solve questions of exercise 11.2, which is related to construction of chapter number 11 for class 10. Hello my awesome students, welcome back to my channel Akshar. I am Nana and I usually make videos related to NCERT solutions for mathematics for classes 9 to 12. So let's have an introduction of this video. In this video you are going to understand that how to draw a tangent on the circle if the given point is outside the circle, and we will solve the question number 2, 3 and 4 of exercise 11.2. And for the remaining questions, link is given in the description box, so you can check out videos from there. So let us start our today's topic, which is the questions of exercise 11.2. Okay, of class 10th, questions of exercise 11.2. Second question. First question I have explained in my previous video, so you can see my previous video for that question. Okay, so see what does this question says. Construct a tangent to a circle of radius 4 centimeter. What is given to you? That there is a circle whose radius is 4 centimeter and you have to construct tangent to this circle. What next condition is given to you for drawing the tangents is that from a point, where is the point from where you have to draw? On the concentric circle of radius 6 centimeter. So the point is on another circle which is concentric. Concentric circles are what? Concentric circles are those whose center is same but the radius is different. So while taking this only as center, O as center, draw another circle of radius 6 centimeter. Okay, so this is the point on the circle from where you have to draw tangents to this smaller circle and you have to measure their lengths also. Okay, so how you are going to proceed that? I have told you that you have to first draw a circle of radius 4 centimeter and then draw another circle by taking this as center of radius 6 centimeter and then join O and P. And the remaining question will be same as we are doing till now. So let us start solving it. So first open your compass equal to 4 centimeter, right? Take it as center. So this is my 4 centimeter, right? Now another concentric circle which is of 6 centimeter. So this is my base and I am going to draw another circle of radius 6 centimeter. Okay, right? So join these lines and give them name. So suppose this is my you can join it anywhere on the circle, on the external circle. So this is OP and this is my 6 centimeter and this is my radius of my smaller circle. Okay, so this is my 4 centimeter. Okay, so what is the next step? Next step is that whenever we are drawing any tangent from external point to the circle, what we do? We join the point with the radius and bisect this line O and P. Then wherever it is going to meet this line, suppose it is meeting the line at point M, then taking MP or MO as diameter, we draw another circle and at the points at which the points this is going to intersect our given circle are the points where the tangent is going to be drawn, right? So we are going to follow the same process here now. What we have to do? We have to first bisect this line, point and the center, the line joining the given point and the center, right? So given point is what? From where we have to draw the tangents is P, the point which is lying on the outer circle. Okay, and we have to bisect it. So how to bisect it? Open your compass little bit more than the half of this line, right? Then draw an arc above the line and draw an arc below the line. Okay, then draw an arc above the line and draw an arc below the line, right, with the same compass. Okay, so always try to draw these things in dotted part because it is not given to you. You are drawing these things by your imagination only. So what is given to you, draw that part as straight line, and what is not given to you, draw that as the dotted line. Okay, then this is my point of intersection. Let us suppose give this name as M, right? So now my line is bisected in two equal parts, right? So now what I will do, I will take either MP as a radius, M will be my center. Okay, so you can take either MP as radius or MO as radius. It's up to you, but center will be my M only. So wherever this is going to intersect my smaller circle, that those will be my 2 points where the tangents can be drawn. Okay, so this is my 1 point and this is my second point. So these are my required 2 tangents of the circle. Okay, so you have to do what next step? Next you have to measure these tangents also. So how you are going to measure it? So measure it, these 2 tangents should be equal in length, right? So see, these are coming equal in length. 4.2 is this and this is also my 4.2 centimeter. Understood? So whenever you have to draw tangent from a given point to the circle, then what are the steps that you have to join the center and that point and then bisect that line, then take the bisected point as the center and radius as OM or MP and draw the circle. The circle which is intersecting this given circle at the 2 points, these 2 points will be the point of the contact at which your tangents can be drawn. To justify this question, what you can say that suppose this is my point Q and this is my point R and I have drawn radius from the center of the circle OQ. Okay, so what I can say that since angle PQO is equal to 90 degree because it is the angle formed inside a semicircle. So angles formed inside a semicircle are of 90 degree. So you can see that this angle is being formed inside a semicircle. So that means this angle is going to be of 90 degree. So that means OQ is perpendicular to PQ. So this is the thing. So that means PQ is tangent to the circle, tangent to the given circle. Okay. Okay. So moving to question number 3, which says that draw a circle of radius 3 centimeter. So let us draw a rough diagram first. Draw a circle of radius 3 centimeter. Take 2 points P and Q on one of its extended diameter. Right, so what is given to you is that there are 2 points on the ends of the diameter at a distance of 7 centimeter from its center. So from its center, so this is 3 and this is 3. From its center 2 points are given to you. This is suppose R and this is suppose my S point, right? So this is 7 centimeter and this is also 7 centimeter. That means OR is equal to OS is equal to 7 centimeter. Okay, then draw tangents to the circle from these 2 points P and Q. From these 2 points you have to draw tangent. So my OP is equal to OQ is equal to 7 centimeter. Okay. So this is a similar question which we are doing till now, but the difference is that Earlier only one point was given to you which was exterior to the circle, but now 2 points are given to us, and from these both 2 points we have to draw tangent. So total of 4 tangents we have to draw. So first draw this smaller circle with the radius 3 centimeter. Okay, so draw this circle which is having radius equal to 3 centimeter. Okay, so one point is at a distance of 7 centimeter from here and 7 centimeter from another point, right? So this is my 7 centimeter. Okay, and this is also 7 centimeter away from the center. So this is away 7 centimeter from the circle. So this is my point P and this is my point Q. So these are the two external points from which you have to draw the circle tangent. So how we proceed when any exterior point is given to you? We simply bisect this line. And so how to bisect this line? Open your compass a little bit more than the half, right? So you can open it and draw an arc, one above the line and one below the line, right? Taking this point P as center and the next time taking this point O as the center. So this is going to be my bisected point of this line, that means OP. So join this. Okay, if you are going to join this, then what you will get? You will get this point, suppose M. Similarly, I can do here also, that means I am going to bisect this line also. The difference only in this question is that this time two external points are given to me. So from those both of the external points I have to draw tangents. So I will follow the same process. Right, how many points are given to you, how much points are given to me, the process is going to be same only, right? So join this also. So now with this point, suppose OR, this R point, this OQ is being bisected. Okay, now give them name as A, B, C and D. Do not forget to give names to your line segments in your exam. Okay, so now next step is what? Next step is that taking M as center and OM as radius, M as center and OM as radius, draw a circle which is going to intersect our given circle at 2 points, right? So draw this circle which is going to intersect our given circle at 2 points. So these are the 2 points. Okay, similarly for this point also what you will do, taking R as center, draw a circle which is going to intersect our given circle at 2 points, this and point this, right? So give them names, suppose any name you can give, E, F, G and H, right? So when you are going to join these 4 points, then you will get your what? Then you will get your 4 tangents. So this with E, this with my F point and this with my G, and we have to join this point with the H. Okay, so these are my 4 tangents, right? To justify this question, what we will do, we will draw an radius from this point E. Okay, and we will draw a radius from this point R. So we know that radius is always perpendicular to the tangent. So that means if somehow we can prove that PE is perpendicular to, OE is perpendicular to PE. So that means I can say that PE is the tangent to the circle. right? So we can prove this thing for all the four tangents, right? So how I will prove that? You can see that this angle PEO is being formed in a semicircle. This is my semicircle, right? So angle PEO is being formed inside a semicircle. So angle PEO will be equal to 90 degree, because angle inside a semicircle is of 90 degree. Inside a semicircle is of what? Is of 90 degree. So that means OE is perpendicular to PE, because between which two lines this angle is formed? PE and OE. So that means OE is perpendicular to PE. Okay, so you can prove the same for all the four remaining tangents. I will draw tangent radius from this point. Then you can say that OG is perpendicular to QG. OG is perpendicular to QG and OH is perpendicular to QH, because these angles are of 90 degree, because these angles are formed inside a semicircle, and angles formed inside the semicircle are of 90 degree. To next question, question number 4, which says that draw a pair of tangents to a circle of radius 5 centimeter. So what is given to you? A rough diagram. Let us draw first rough diagram. That any circle is given to you whose radius is 5 centimeter. Then you have to draw pair of tangents to this circle. You have to draw two tangents to this circle which are inclined to each other at an angle of 60 degree. Okay. So how you will draw this angle 60 degree? How you will came to know that? Where you have to draw this point P and how to get this angle 60 degree? We will start the question from the reverse. That means we will find out the other angles of this quadrilateral, and then automatically this angle is going to be of 60 degree. So you can see that suppose this is Q point and this is R point. So you can see that very clearly. If I am going to join this OQ, that means radius, this OR is also a radius. So by the theorem 10.1, what is said? That any radius is perpendicular to the tangent. Okay, here also any radius is perpendicular to the tangent. So that means this angle is of 90 and this also is of 90 degree. So this OPQR is a quadrilateral, right? So if this is a quadrilateral, so that means sum of all angles, this is my fourth angle, sum of all angles will be equal to 360 degree. So that means 90 degree plus 60 degree plus 90 degree plus this angle O, all angles will be equal to 360. So 90 plus 90 will be 180. 180 plus 60 will be 240. So angle O will be equal to 360 minus 240, which is going to be equal to 120 degree. Okay, so instead of drawing this angle, we will draw these three angles. So automatically this angle will be of 60 degree. So what we will do? We will draw an angle of 120 degree on the diameter of the circle, right? So let's proceed how to do that. First we will draw a circle of radius 5 centimeter. Okay, this is my 5, this is my circle of radius 5 centimeter, right? This is a circle of radius 5 centimeter. Okay, so this is my radius of 5 centimeter. Okay, so take any diameter. that will be the simpler one. Okay, so now I have to draw this angle 120 degree, right? So if how to draw the angle of 120 degree, first we will draw an acute angle from here. This will be my angle of 60 degree, and when I will take this arc as center and draw another arc, then that will be my angle of 120 degree. Okay, or I can say that my this angle is of, if my this angle is of 60 degree, then automatically my this remaining angle is of 120 degree. Okay, so this angle 120 degree will be a part of the quadrilateral, right? So if I will draw a radius at this point, so this is my side of the quadrilateral. Okay, let us suppose this is my R, right? So we know that, so and suppose this is my point Q, so we know that these OQ and OR are the radius of the circle, and radius of the circle are always perpendicular to the tangent at the point of contact, right? So we have studied this thing in our previous chapter, theorem number 10.2. so what we will do, because it is perpendicular to the tangent, so we will draw an angle of 90 degree. Okay, so how to draw an angle of 90 degree? First we will draw an angle of 60 degree, then we will draw an angle of 120 degree, and then we will bisect both of these angles. This angle will be equal to 90 degree. So this is my angle which is of 90 degree, right? Similarly, I will draw angle of 90 degree at the point Q also, right? So draw the angle this first 60 degree, and then an angle of 120 degree, and then draw the midpoint of these angles, means bisect the angle of 60 degree and 120 degree, so that my resulting angle is of 190 degree. Okay, so extend these two lines till they are going to intersect each other at a common point. So that point is going to be point of my exterior to the circle. So let us suppose this point is point P, right? So automatically this angle is going to be of 60 degree. So automatically this angle is going to be of equal to 60 degree. So this is the quadrilateral which has been formed, about which we were talking from the starting. So see, this is the quadrilateral. Okay, so this is the quadrilateral. So my angle 120 is of quadrilateral. Okay, if you find this video useful, then please do like, share and subscribe my channel so that you can get more updates of my new videos. So let's meet in the next video, in which we are going to solve the remaining questions of exercise 11.2. Till then, take